Go exterminate yourself. Oh, it's running? Hello everybody, welcome to Pond's Python practice. Today I'm going to be talking about how to survive the Spaceship project for IIPP. And actually, my Sonic can be thought of as the spaceship. Because you see, I'm moving it in the direction of the forward velocity, then I change it and keep moving it. And what else does the spaceship need to do? It needs to fire a missile and maybe even play a sound when that happens. Okay, so the complicated part of that is the actual motion. And Professor Joe said something about vectors and friction and that all sounds kind of mathy. But it's okay. It's actually not that hard. So we know that position is position. We'll start with that as our base. We'll say that velocity is change in position and acceleration is change in velocity. So how can I show that? Well, okay, say we have a number line here, all the way over here. And our initial position here is 0. Well, let's say we have a velocity of 0 and an acceleration of 0. Well, we're starting here, so we don't do anything. But then let's say the acceleration becomes 1. That's a 1. So then the first update, we don't move, but then the velocity becomes 1. So then the next update, we move over 1. Then acceleration is still 1, so velocity becomes 2, and we move over 2, and so on. It would then be 3. Okay, so then if the velocity then becomes negative, the position is updated, and then the velocity is, which brings it back down to 2. So we still go forward 2. And actually that keeps up until the acceleration gets all the way to 0, and then we decelerate and come back this way, something like that. Okay, so how does that actually help us? Well, that's where vectors come in. Vectors may sound kind of scary, but all it is a measure of things. So, what would you do if you're starting here at this origin and you want to go up to here? Well, if you're just drawing it, you would go out 1, 2, 3, and up 1, 2, 3, 4. Okay, and you'd make a nice little triangle there. And so what's the distance between these 2 points? Well, you can apply the distance formula or whatever. Or you could write it as a vector. You could write it as a vector of magnitude 5 at a direction of 53 degrees. I know that because this is 4, this is 3, Pythagorean theorem says this is 5, and I googled this angle. So either way is the same. At any given update, you go over 3, up 4, or you move a distance of 5 at an angle of 53 degrees. So how does that help us with the spaceship? Well, it's moving in the direction of the forward vector, which actually is a unit vector. So I'm going to drastically change my scale and call each 4 squares 1 unit. So we're going to need a unit circle and I don't have a protractor for markers. So here's the origin, and let's say that we're at a 45-ish degree angle. So then, what's this point? Well, we can go back to some basic trig. We've got, let's call that a 45-45 triangle. So the sides are 1, 1, square root of 2. So we're trying to find this angle. And you can just trust me that the coordinates of this angle are cosine, sine. So this point's coordinates are 1 over root 2, 1 over root 2. So then for this object, at each update, it moves over 1 root over root 2, and it moves up 1 over root 2. So then, let's say this is the same object with that velocity. It'll get updated. It'll move to here. Its new position is here. So we've got a circle and a velocity, and it'll move it, and I'm bad at drawing and talking at the same time. And it could get a new velocity and go over that way, or even a new velocity, and yeah. Anyways, so how does that help us with the spaceship? Well, remember, we're drawing the spaceship as a circle, and it has a angle which is representing a unit vector, which is the forward vector. How does that help us with the spaceship? Well, we need to remember what we're given. From various sources, we know that the ship has an angle, position, and velocity, among other things. And the template actually gives us a function that will change the angle into a list of an x and y components for us, and I'm going to call that decomposition. And we're also given an equation for friction, and that acceleration equals thrust plus friction, and we already proved that. The ship is only under thrust if the up key is held down, so we need to actually treat these two things separately. The easy thing is friction. We're given this equation in the videos. Velocity equals coefficient of friction times the velocity plus the thrust. So all we need to do to apply friction is just say velocity times equals 1 minus friction. The thrust is a little bit harder. The thrust is actually just the decomposition of the angle because the draw handler is called so often. So it's a little bit harder, but it's still easy. What you're going to want to do is, if thrust, then you're going to want to decompose the angle, and you're probably going to want to store that. Then you're going to want to add the x velocity to the x component of the decomp, and then do that for y too. So this actually is very, very simple. The draw function, the update function, all it's going to do is it's going to update the position, and you need to remember modulo dimension, because you can say position equals the update, but it'll just keep going and going until it goes off the screen. But if you put update modulo dimension, it'll keep going, then it'll reach the edge of the screen and just wrap around, and keep going and wrap around. And if you look carefully, you can almost see that flicking moment there. So anyways, the update function is It's going to just update the position, and then the forward vector and the angle, and then remember to apply the thrust and to apply friction. There are also a couple of other minor things you need for the ship class. You need to write helper functions to change the angle, because otherwise you're not going to be able to rotate. You're just going to be stuck flying in a straight line, and what fun is that? And you're also going to need to add something to find missiles. The other tough thing with this is the sprite class, which I'm going to need to go to Code Sculptor to explain.
I'll explain the sprite class by going over the template. So the sprite class is hard because it takes care of the rocks and the missiles, and you'd think two different types of objects need two different classes, but no, actually. They are a lot more similar than you'd think. They're created with an initial position and a velocity and an image and some sound info, and all they do is they move, and they do not have any outside forces acting on them. So they just move in a very similar thing, and they may or may not rotate. So the only difference really is that the missile has a sound plate when it spawns. So you initialize all of the things like a normal class would, and then you need to draw the sprite and update it. And of course you also need to create things. So you create a rock, obviously, in the rock spawner. So you would, this is not the actual code, you would just say that rock equals, sprite with the things. And then, as it says in the development process, for the missile, you would def spawn with self because it's a class function. And then you would just say that missile equals sprite with the things. So the other interesting thing is sounds and images. So for sounds are easy. Just make sure that you are using Chrome because Chrome is awesome. And also, sounds may not work properly in Firefox where they do work in Chrome. And then for Code Sculptor, it's a simple GUI command, just simple GUI.load sound, and then you put the URL of the sound on in as an argument as a string. And you can do that for as many sounds as you want. And also, if there's a sound that needs a certain volume, make sure that you set the volume. And the image is similar. Simple GUI.load image and put the URL of the image in there. And actually, with the image and with the sound too, you can check to make sure that it's okay by just copying it into a new tab. And you see this is the explosion image, and you see it's a tiled image with a sequence of things, and you know all about tiled images from Blackjack. Now, the hard thing is making sure that your images are actually accessible. And obviously, the ones in the template are accessible, but again, if you use a custom image, make sure you test it on multiple computers. Now, the interesting thing that you'll notice is that we put an image info class, and that just holds all of the stuff about the image itself. And if you look back down at the ship class, you see that instead of self.imageCenter equals whatever the image center is, it's info.getCenter, and we feed the info object in when we create the ship class. Good luck on your mini project!